Welcome to Precalculus Concept 6a, Probability. We're going to learn how to compute empirical probability, and there's 3 boxes. So box number 1, let's talk about what empirical probability is. Empirical probability applies to situations in which we observe how frequently an event occurs. How frequently an event occurs. So we use the following formula here to compute the empirical probability. So the probability of an event, so P of E, so this notation says the probability of an event is equal to the observed number of times that the event occurs over the total number of observed occurrences. Sounds a little bit funky, but once we see an example in box number 2, it should make some more sense to you. Box number 2 is an example taken out of the book. It says table 10.4, mammography screening on 100,000 U.S. women ages 40 to 50, and they give you a table. So let's try and dissect this table just a little bit. Up at the top, they have 2 columns. They have breast cancer and they have no breast cancer. On the left-hand side, they have a positive mammogram and a negative mammogram. So the number 720 represents the women who have a positive mammogram and breast cancer. The number 80 represents the number of women who have a negative mammogram but do have breast cancer. Okay? And then the grand total of 800 is all total women who have breast cancer. Over here, no breast cancers and a positive mammogram are 6,944. And no breast cancer and a negative mammogram, 92,256. So the combination of these two, 99,200, are women who do not have breast cancer at all. Okay? If you add sideways, then this number right here gives you the women who have positive mammograms. Okay? And if you add sideways here, it gives you the total number of women that have negative mammograms. So that's how you dissect this table. It's important to understand what all the columns and the rows mean. So part A says, find the probability that a woman has breast cancer. So the probability that a woman has breast cancer is the number of women with breast cancer divided by the total number of women. So if we look, what is the total number of women with breast cancer? So we want to look in this column. So I have 720 plus 80 gives me a grand total of 800 women that have breast cancer. Total number of women is given to us up at the top. That's 100,000. 100,000. So this fraction is 1 out of 125, or 0.008% chance. 3b is a little bit different because we're going to change our denominator. We're going to restrict our domain. So part B says, among the women with positive mammograms only, find the probability of not having breast cancer. Okay, so we have restricted our domain to among the women that have positive mammograms only. This is going to be our denominator. So the number of women with positive mammograms only is the sum total of this row, 720 and 6,944, which of course is 7,644. So this is our new denominator, 7,664, 7,664. Because these are the women that have positive mammograms. Now, out of those, what is the probability of not having breast cancer? Well, that number is defined for us right there. It is 6,944. So 6,944. So that's the number of women with no breast cancer out of the total number of women that have a positive mammogram. So when you run this through your calculator, you get 0.906 chance that among the women with positive mammograms, they do not have breast cancer. So this is empirical probability because our denominator has changed because we're only considering the women that have positive mammograms. Okay, box number 3 is a you try. It says, find the probability that a woman aged 40 to 50 has a positive mammogram. So we're talking about, of all the people find the probability that they have a positive mammogram. Hopefully you got the right answer of 0.07664 or 7,664 out of 100,000. So we want the total number of women that have a positive mammogram, so we take the sum total of these two and we divide it by the grand total of in the study, which is 100,000. So you can either leave it as a fraction or you can turn it into a decimal.